calculate.
You put it right there.
I get so excited about calculating.
Do you put like this calculator fit in a bag? How does this work? It's stretched and still would not fit.
Okay, here's what we're going to talk about today. Obviously, yesterday you had a bunch of problems where you had to do transformations. Some of you asked, and I'm totally fine with that, that on some of those problems, instead of, I think one of the problems was something like this. You can move it around, you can change it. If you wanted to explain in words what you were doing, I was totally fine with that you're stretching it vertically or you're shifting it right or left. But you have to be very specific when you told me that. You couldn't just say it's going left without telling me it's going left 3 spaces. So just keep in mind, I want it very specific if you're explaining words. Okay? Those are for the ones that were withdrawing. So I'm going to get rid of this. That was just short and simple to the point. Yesterday, I think I put all the pictures we did from the slide, because I was doing Desmos. I took screenshots of those. They're on the website, so you can see each thing that we did and how it manipulated the graph. I thought that was just the easiest way to do it. Okay? Next thing. The new stuff we're doing today. We're in the 4th section today. So we're in section 1.4. This stuff is kind of starting to mix everything together now. Obviously, we've been looking at graphing a lot, looking at like linear functions, exponentials. The goal today is logarithms.
Stop making that sound.
This is my logarithms. I'm gonna hold you for that.
Okay, now the thing is, if you think about this, we did logarithms a couple sections ago. But I want to make sure everyone is getting those calculations right. You know how to type stuff in. Not just for calculating what's left, because a lot of the homework that you did a previous couple sections ago was just merely what was the percent. When you looked at a formula, you could rattle off what those numbers were on the formula. The goal today is we're going to actually look at logarithmic equations for any type, not just exponential, but just random functions that were exponential in nature. Something like this, where this number doesn't have a perfect number to it, right? That if I were to try to guess the x, that would be involved, 3 squared is 9, 3 to the 3rd power is 27. Like this is some weird decimal in between there. So this type of problem is why we have logarithmic. We have to talk about the basic properties today. I'll give you 1 or 2 examples and then we're done, okay? So to talk through this problem is exponential because it has a power that's a variable. So what we talk about is you have to look at the base. Is this base, is it the natural number e? If it's not the natural number, then you're taking the normal logarithm of both sides. So in my case, this is what I'm doing first. And again, what told me to do that is the base that has that power. If the base was an e, natural number e, I would use a natural log. If it's any other digit, I use a normal logarithm. Now, here's one of the first properties we've actually discussed in here. This is something we did, a week ago. This power can drop out front. That was it's called a power rule for logarithms. That the x can literally go out front here. Now, we did not discuss why you can do that, but I discussed that last week. You can drop powers out front. Is there any questions with how to do that step?
No.
Next step, to solve for x. Solve for x. You would divide this logarithm over. Because you want to get this by itself, so you have to do the opposite operation to the other side. Log of 15 divided by log of 3. Now, what these logarithms stand for. There's an easy way to do this. When you actually divide these, you could actually write this as 1 logarithm. Some people have the luxury of typing 1 logarithm into their calculator. This 3 is technically the base, and the 15 on the top is the actual term that we're calculating. Log base 3 of 15. But I'm betting 90% of people in here probably have to type it in like this. There's a few calculators in here that have the luxury of actually entering a base number. When you actually hit the log button, it'll ask for both numbers.
Look, can you do that?
Okay, what number are we getting?
2.461.
2.46.
I got 2.4649735.
Okay, you guys get the idea. Okay, that number made sense. It fell between 2 and 3. It was probably closer to the number 2 because the answer 15 is closer to 9 than it is 27. So that's why 2.46.
I was gonna say 2.46 when before we calculated.
All right, questions on the logarithm. Now, why this property actually works? Because what logarithms actually stand for. Logarithm is what you're using to find a power. That's basically what it is. You're finding the power up here. Why you can multiply it out front is if this is a power with another power, you can actually multiply them together because it's falling back to the power rule on exponents. Something like this. Now when you have powers and powers, you can actually multiply these together. That's what it's doing here. Logarithm means a power. This was a power on it originally, so you can multiply the two together. It's following that basic property where you go 2 times 4, that type of idea. Again, I made up those numbers. But that's the concept of why this property actually works. We have a few other properties that you need to know. And this is the last stuff that I want to cover today because it's pretty straightforward. The other properties for logarithms, other than the power rule, let me write this one down again. Log base 4 to the x. You can drop this out front. This is your power rule. Okay, does everyone have that one written down?
Sam, where's the log button?
Second property you need to know. So that was the first example. Second property that you need to know is if they're ever multiplying things on the inside of a logarithm. Let's say like 3 times x. They're multiplying things inside a logarithm. You can separate these into their own log, and you can add them together. That is called the sum rule, the product rule. This is what it would turn into. 2 things being multiplied on the inside can separate out. Why you'd ever want to do that? I remember doing that very vividly on my math placement test at Iowa State. They gave you an answer key in the upper corner because they don't allow you to use the calculator on that test to place you in a certain math class. Well, one of the questions was this. Calculate the log of 6 without a calculator. I don't have anything in front of me. And they want to know the exact answer for the log of 6. So what that is, what this stands for, it stands for this. What power do you put on a 10 that gives you the number 6? That's literally what that thing stands for. Well, I can't just guess at those numbers. So what you could do, if you were thinking about this, and you looked at the answer key in the upper corner of the test, they gave me a couple things in the upper corner. One of the things they told me was log of base 2 and log of base 3. They gave me these decimals in the upper corner. Now, I don't even know what they are. They just happened to give them to me in the corner.
Let me tell you.
Yeah, log of 2.
.301.
Okay, what's log of 3?
0.4771
okay.
547.
So they gave me those two numbers in the upper corner of the test. Well, if you're using this problem and you have this idea, this property of logarithms in your head, I can separate log of 6 to 3 times 2. And yeah, then what I can do is this can separate into their own logarithm. And all I have to do is add the 2 decimals together. Because I know what the log of 3 is. They had it printed in the corner of my test. I know what the log of 2 is. They had it printed in the corner. I could add the 2 together in my final answer. What's that? Without needing a calculator in front of me. Questions at all? Is that right? Log of 6? Is it roughly about that? All right.
778151125.
Yeah, if there's more decimal places.
Yeah, that's close.
Okay. All right. Questions on that?
That was just too easy. That was,
Yeah, I know. It was literally, that was one of the problems on my math placement test.
well, maybe it was like to see if you're ready for it.
That's exactly what they're doing.
What?
Oh, are you ready for calc? I already tested out because I already taken calc.
Oh, boy.
They don't even ask you that question. They're just like, well, take this test. All right, we'll take calc 1. That'll be fine.
So we'll be fine in college, you're saying?
I won't be more than fine.
Oh,
More than
okay. You're confident.
Oh, I'm very, very, very. All right, let's go to the next one.
I wouldn't be so.
Next example. the quotient rule. Something like this. If you're dividing two things in a logarithm, you can separate them into their own logs, but now you're just subtracting top minus bottom. That's a basic property. Again, I can do that for the number 6 as well. If they happen to be printing things for like log of 6, and maybe they didn't tell me 3, they told me 12. Okay, and they gave me whatever that number is. Well, I know that the log of 6 is 12 divided by 2. Well, now I can just make that a division rule and subtract the two decimals from each other. Log of 12 minus log of 2. Because I can follow this basic property, top minus bottom. Just subtract the two logs, if I knew the decimals. Which is that 0.778 number. Okay, last basic property today. We talked about the product rule, talked about quotient rule, or sum and difference, talked about the power rule. The last thing is if they give you things that are in the powers. For instance, if they do something like this, 10 log of 5. So it's some number to a power of a log. The log's in the power. If they have the same bases, which they do in these cases, these have the same basis, they would literally cancel out, and we're left with the 5.
That's incredible.
Okay, those are the basic rules we talked about in pre-calc. Tomorrow, we're going to jump in depth and start using these all together. Okay? There's a few more because we still have to talk about the natural number. But these are things we're going to discuss tomorrow and talk about where they come from. Okay? The rest of the time you have today, you can work on your page 26. I'm going to give you time in class because I know it does take time. So you can ask questions, you can get it finished, and then do tomorrow.